Introduction to Checkpoint Technology. Hey everyone! So we're going to begin by discussing firewall and where it lies in the OSI model. And we're going to speak a bit about OSI model so you understand just the basics of networking. The next thing we're going to discuss is the difference between packet filtering and stateful inspection firewalls. By the way, Checkpoint and the stateful inspection. Okay. The last thing we're going to discuss is Checkpoint architecture. It might seem a bit overwhelming because too many components Checkpoint has, like Smart Event, like Smart Workflow, CloudGuard, SandBlast, Smart Management, Gateway. I'm just giving you things out of my head, but it's way more that Checkpoint has. I'm going to make it a bit way more simpler for you. It's not that complicated, I promise you, especially for R80 types of exams, CCSA related or basic networking skills and administrating skills you need for your job related things. All right, guys. Let's start by discussing OSI. The first layer is the physical one. This is basically where we have actual bits that come and go across the wire, like pulses of light, if we're speaking about fiber optics. The next thing is data link. This is where switches operate, where switches learn the MAC addresses of devices. And the second layer, when we speak about the second layer, we speak about LAN, about local area networking. We're not speaking about routers, we're not speaking about IPs, we're not speaking about anything at all but LAN, local area network. In the networking layer, we speak about packets. The packets what we have is IPv4 and IPv6. This is like basically if the packet is going out of the local area network. It's called WAN, somewhere far away where routers operate. Transport layer is basically how we send the packets. Types of segments that we use here is TCP and UDP. And we're going to speak a bit about this later on. Application, presentation, and session layers. We are not going to focus too much in this series because it's more of like, it might be related to programmers, not to us, not to networking and security type of guys. From the gap here, I guess you've already understood that Checkpoint lies between the data link layer and the networking layer. And to be more precise, firewall lies between the network card and the router. Yes, it kind of operates between those two, but it has its own perks. So we just get into the point how stateful inspection works. And here I have the really small, tiny rule base just to show you how it works. We have source, destination, there is like type of services we have to block, and the action. It's a bit small, but in the labs, we're gonna go really deep into this and how to set it up. All right, packet filtering. So that technology was introduced, I might be lying to you, but I think it was late 80s, maybe the beginning of the 90s. So the way it works, we have the firewall, and we have to specify the rule base. The first rule to allow the client to the server, and the reverse rule to specify the connection between the server to the client. Okay, as you can see, I have the firewall here, and I put it right between data link and network layer. Yeah, just the way I told you, it's still here. All right, so the client tries to connect to the server, which is 909090, to the port 4433. These are two ports that my server is listening to. So what happens when client tries to connect? The first thing, it goes through the data link layer, through the switches and all that jibber jabber. All right, so then it goes to the firewall. The firewall, what it does, it checks the source, it checks destination, port, and the action. If everything is matched, what we're trying to do with our connection, then the traffic is allowed to the next layer and passes through the wire without any problem. So as I told you, in packet filtering firewall, you need a reverse rule. You need a connection back from the server. It will not work otherwise. You just have to do that. That's the technology. Don't blame me. Blame the the technology. All right. So another important thing you have to understand here is that anything that is not allowed will be denied. In this particular instance, I don't have the rule that will allow the port, which is 443. And I'm just showing, I'm trying to connect HTTPS slash 909090 443. Okay, we try to connect. First it goes through the data link layer, then it gets to the checkpoint. Oh, I'm sorry, not checkpoint, just firewall. It gets to the firewall, I'm sorry, typo. And it checks the role base, it's not there. That's it, blocks the connection. It's not gonna work. Because the action is denied by default. It's kind of some kind of implicit or implied policy, whatever. Yeah. All right, so before we understand how stateful inspection works, and stateful inspection is a proprietary thing, that Checkpoint invented. And before we go into that, let's just really briefly discuss how TCP connection works. Okay, so we have a client, we have a server. First, they have to establish a handshake. We send out the SYN packet, and we expect the SYN ACK packet from the server. Right after we receive it, we send out ACK. The second phase is the actual data that we send out through our connection, networking connection. It has download, ACK, upload, push, all kind of different type of flags that come and go. And the teardown part, which is finish, acknowledge that, finish, and acknowledge that from the client side. It's a four-way handshake. The reason why we need TCP is basically to have a reliable type of protocol. If we lose data, it keeps the track of the packets that was lost and the packets that we actually received from the server. Same for the server receiving packets from the client. TCP is a connection-oriented communication, and it's reliable. It knows for sure, it checks out flags, and it knows what sequence number to expect, and that's why it's reliable. Yeah, and for a teardown session, it can be four-way handshake, it can be three-way handshake. They have to kind of like acknowledge that when they like client and server starts the connection. Yeah, same for teardown session. It could be different. Yes, that basically what I explained. It's connection-oriented communication. It's reliable because it knows what kind of sequence number to send. If it's a different sequence number, the server might assume that the packet was lost, duplicated, out of order, and it's going to drop the connection. And it's going to send again. It's like ACK. You kind of get the where I'm going with that. It's reliable protocol. When we speak about UDP, is basically the same thing, except for it's not reliable. That protocol relates to the fourth level of the OSI model, which is the transport layer, and basically how the packet will be delivered. The difference between TCP is that it's connectionless. It has no handshake part session. It has no teardown session. It's not reliable. It doesn't keep track of the sequence number, doesn't keep track of the FIN packets, all kind of stuff that is in TCP session. It's not here. You might say it's not really useful because it's not reliable, which is not true, but it is actually useful. If you are into video streaming platforms or computer gaming, especially online gaming, not especially, only online games, and that's really useful because in TCP connection, if the pixel gets lost or you have a lag, you have to wait until you acknowledge the proper sequence number until you receive the correct bit of information. But in video streaming or online gaming, it might be too late until you actually get the proper packet. It will be too late. So in UDP, let's say you have like a bad pixel on TV, you don't want to wait for the right one because the picture actually changed, in so many different ways in each second. You get the idea, right? So you need UDP because it's fast, it's like not reliable, but screw that. Like we can see the picture, we can see the whole image. That's okay for us. It's way better in the sense of if we need to be efficient and fast. Stateful inspection technology. Okay, guys, so that technology was invented by Check Point, and it's used up until this day by almost 95% of vendors on the market. That's really interesting how it works, and it kind of like packet filtering firewall, where we specify the source, destination, port, and action, whether we want to allow or deny the packet. But the difference is we only need one packet. If we need to open up a connection from the client to the server, we only need one rule in the rule base of the firewall for the connection to work. You don't need the reverse rule, just like in packet filtering firewall. And I'm going to explain to you how it works. The client tries to open up a connection with the FTP server, and what happens is we send out the SYN packet. In our rule base on the firewall, we have the policy, source, client IP, destination, our FTP server, and allow the port 21, which stands for FTP protocol. All right, so we have that in our policy. It passes the traffic just fine, action allow. When the traffic comes back from FTP server, it goes just fine as well. It wouldn't work in packet filtering because you need a second rule. And here, I'm going to explain you how it works. To the right, we have a connection table. What connection table does, it keeps track of everything that comes and goes to the firewall when it's related to the network layer and transport layer. Let's say we have a client trying to open up a session with FTP. It sends out the SYN. As I told you, SYN packet has a lot of flags. It has a lot of types of sessions. The handshake session, the teardown session, when it's trying to finish the session, it has a lot of flags. And okay, so here's the packet flow. We try to open up the connection from the client to the FTP server. First, SYN is checked against the firewall policy, which we have allow. Then the firewall puts all the data for that session in the connection table. So here we have source IP, destination IP, all kind of type of flags that's related to that session. So once we open up a connection to the FTP, our firewall already knows, just like our client, what kind of acknowledgement we expect. So when the traffic goes back from FTP server, Check Point firewall checks his connection table if that flag for that specific connection is allowed. If so, it allows the traffic. It checks, it has all information related to handshake, data transfer, and tear down sessions. TCP is stored for 1 hour for 3600 seconds. If we have a scenario where in our connection, SYN ACK, like the reply from the server we expect, is different, it's not gonna go through the firewall. It's gonna be blocked. If we like step on the wire, if we try to modify the packet, modify the flag inside the our segment, it's not gonna work. It's not gonna go through the firewall because it knows what to expect in our connection table. Okay, so here's the scenario. let's say we already have established session between our client and FTP server. We have SYN, we have SYN-ACK and ACK. So right now we are in data transfer phase. We're sending data without any problem. We're getting all our good stuff from FTP. I usually get music. I'm not sure what you guys get, but anyway, so let's say we have a hacker somewhere outside on the network, and he's a man in the middle. He's trying to modify our session. He's trying to change maybe SYN-ACK, or maybe who knows what he's gonna do. He's trying to change the flag of our session. Oh no, he wants to send a finish flag, finish our session, but it's gonna be out of state. Checkpoint firewall is gonna drop it out of state because that connection his fin flag connection doesn't belong to our connection. It's gonna be dropped. If he is trying to send his own data to the client, like pretend he's actually FTP server, so he can put some malicious stuff on our client side, it's going to be dropped because it's going to be out of state, because the type of data for that TCP connection he's going to send us is going to be different from what we expect, from what firewall expects from the FTP server. The sequence number in TCP session is not going to be exactly like 1 and we expect 2. It's going to be absolutely different. So it's kind of like it's going to be random number and we expect the following number. Let's say it's going to be 122 and we expect 123. But it's going to be different for each session. So that's why it's kind of impossible to guess.